So let me introduce the first building block in Beacon Tower. It's called the provider services. And essentially what provider services do is that it makes it possible for us in Beacon Tower to integrate to all sorts of different data sources externally without having to change the core of Beacon Tower, which is otherwise a problem if you do not foresee that you will have all sorts of different and all sorts of unknown data sources in the future. When you make your own IoT cloud platform, that might be a challenge to have an architecture that can actually handle that. And that's why we have built the provider services component in Beacon Tower so that we can handle all sorts of different data sources. And that means that we can receive data from external systems that might be weather forecasts, energy prices, it might be device clouds, data from all sorts of connectivity solutions. It can also be from edge gateways, and it can also, of course, be directly from all sorts of different devices with different data formats, sensors, and different OT, SCADA, MES, and other sorts of automation systems. And they can deliver the data, whether it's in a streaming format, in a batching format, or we query to get the data. So everything is possible in that sense. And then we process all the data, and then we make it available through APIs, as I've said, to other types of systems as well. And we also, of course, have our own cockpit and our own user face to Beacon Tower that we will see later on in the demo. But otherwise, it can also all be exposed via these APIs and used in other projects, such as analytics and AI, machine learning, business systems, and other product and optimization tools. And also a small point is to say that these provider services can, of course, also receive data and read data from these internal systems, which is not completely related to the devices that you might be handling in your IoT solution. So Beacon Tower can also enrich the machine data with the internal IT system data. Moving on from that, another building block and concepts that is important to emphasize in Beacon Tower when going forward is our use of asset models, and I will try to keep it short. Our use of asset models is a way to structure in the cloud what kind of telemetry signals, what kind of properties, and eventually what kind of commands that we would like to support to invoke on the device from the cloud. And we essentially have to make an asset model for each different type of physical device. And we can call it in this slide a one-to-one asset model, which is kind of the same as a digital twin or a digital shadow. So that actually just have the responsibility of handling the data signals from the physical device. And if we then have more than one type of physical device, then we actually just have to make another asset model. And if we have, of course, I would say more than one example of that type of physical device, then we have to instantiate the corresponding asset model so that that specific instance handle the data streams from that physical device. And the way it's done in the background is by using something called DTDL, which is short for Digital Twin Definition Language, which is a language that Microsoft have made and open sourced. So it's completely open, and it's more or less as a standard these days of how to describe a device in the cloud as a digital twin. And we have, of course, made a user interface to handle the way that the DTDL language is defined, so that you don't have to, as a user, understand exactly how to put in these details. And then we have the data from the devices structured in digital shadows, so to speak. And then we can build on top of that business models that correspond to your business needs, whether that might be organization aspects, location aspects, a process aspect, or grouping it into different asset groups. Could be grouped by device model or device state or other sorts of asset groups. And then the last beacon tower concept I will introduce is our use of hierarchies and ways to structure these instances of asset models. So they can be put into all sorts of different structures or hierarchies that corresponds to your business needs. And you can make an unlimited amount of business structures so that you have a different structure that corresponds to that particular person's business needs. So that's a way to be very flexible about how you can actually work with the data within Beacon Tower, but also it's a way to structure the data that can then later be used in other systems, because the way that we structure the data is also exposed via APIs, so that you can use these new asset definitions, aggregations of assets, dashboards, and nodes as these assets structures are corresponding of. You can use them externally as well, so you don't have to make these business interpretations of the data once again. So that was a short introduction to these concepts, and now I will pass the word on to you, Michael.
So as Jacob mentioned, there's a multitude of reasons that you might want to have data from other sources or from any sources into Beacon Tower. The most common one we use is the IoT hub, because that's usually where you have IoT devices communicating directly with. But I mean, it doesn't need to be. You might use other cloud services, IoT clouds or similar, or any other type of source simply to get telemetry data into the system, weather data or other things that you just want to bring in and be able to view and work with just like any other devices you have. But then there are other reasons that you might want to do this, and we're going to show you quite a small example, but a bit more advanced one where we make use of using external data to add value to an existing device. And what you see here is an example of car chargers. And what we're going to do is we're going to add cost steering based on current spot prices to those. And talk a bit about how we do that. But to begin with, just so what you see here is a view of one specific asset. As you see to the left here, we have a small tree built up, and these can of course be much bigger and more advanced, but this is simply showing two different charging stations. And on these charging stations, we have two types of chargers. We have one type with a battery and one type with just normal charger. And it doesn't make it, there's no problem of mixing these, because we can always in different ways normalize data, meaning that we can, even if data that comes in goes to different models, we can then normalize it in a way where we can visualize them together. Of course, as long as the telemetry going into them is comparable to in some way. The devices that you see connected here, that's simulated devices, just for information. And this is usually a way that we work with when we test and develop things, of course. But the devices behave exactly like the real world devices do.
And you should probably also add that the data is sent to Beacon Tower exactly the same way as they would be sent as if it was a real device.
Exactly. So the data from these devices you see here goes through the IoT hub, just like any other device would usually do, unless we choose other sources, which is what we're going to look at here. So the basic we're going to do now. So we have these devices here, and the basic data we have. This is one of the batteries. We have some battery information, what charging level the battery has, and some other information. So what we're going to try to do now is that we want to add data from Nord Pool. And there are a couple of different ways to do this, depending a bit what you want to do. But the way we've done this is that we developed an integration to Nord Pool where we can pull out prices. And we bring this in as telemetry data, as any kind of telemetry data. And you could do that directly to a device like this. But what we've done is that we created an asset which which is very basic. This is an asset that looks at, so this is called SE4, which is one of the 4 Swedish price areas. And what it does is simply it takes data from this hourly data, which we can see here. We're only looking back a couple of hours here. So it's hourly data from Nord Pool that we take in. And now we want to connect this data to one of our chargers. To visualize this a bit, we'll actually start with looking at creating a new asset, the way we go about choosing different service providers. So when I create let's say that we also want to bring in data from another price area in from Nord Pool, like price area 3, for example. So we would just give this a name. We will choose a model, and we already have a model. We shall show you slightly a bit later on how model looks like and how we work with them. But we have a model called Nord Pool, which is very basic. It has more or less just a value and a time. So it's what the price is as at a certain time. We'll call this Nord Pool SE3, and then we'll use this, and there are two different types of assets. One means that it's based on a provider service, which is that it gets the data directly from somewhere from the outside of Beacon Tower. And another one is based on assets, which means it's an asset that takes data from another asset or multiple different assets. And for example, the idea with this can be that you can combine two assets into one. For example, if you want to visualize different components as one bigger machine, or it can be that you actually create another asset with less information on it that you maybe want to make available to a customer. It doesn't need all the diagnostic information, it only needs what's valuable to them. But in this case, we're going to get data actually from an outside, so we choose a provider. And in this case, we would use the Nord Pool provider. We will also add, in this specific case, I know that what we do is that I write in SE3 means that this is the data that the provider will take, the provider service will take from Nord Pool into this one. So if I want SE2 or 1, I would write that instead. So that's the basic of making use of different data providers. And of course, we can have a range of different data providers. Some are standard, some are customer specific ones, of course, for their systems. But that's a simple thing just to take data from different sources. And it's also actually possible to take data into one type of model from different sources. You could have, for example, Nord Pool, you could have a energy value coming in either from a Danish equivalent to Nord Pool or from Nord Pool, and just have two different providers providing data into that. I'm not going to create this one now because we already have one existing that we're going to use. But I'm going to show you the other part where we actually make use of this data on one of our car chargers. So if we go back to models and we're going to look at one of our slightly more advanced models, which is the car charger here, which is the one that you saw before. And what we do here is that now we want to actually make this car charger make use of data from another asset. And then when we want to do that, we use what we call a binding. A binding describes how we bind one asset to one or multiple other assets again and obtains data from them. And I'm gonna add a binding, and I'm also just gonna show you this basic part of how this works. So in this specific case, we have this Nord Pool telemetry value here, which doesn't contain data on itself, but I want to fill that with data from this Nord Pool model or asset I did. So I simply select the model, which is called Nord Pool. And as you also see here, when I do that, I don't select if I want to have the one that was price area 3 or 4, because I only select the model itself. And what this means is that if I create a car charger, connecting to Nord Pool, what actually happens then when I create an instance of that car charger is that I have to select which Nord Pool source I want to use. So if it's a car charger installed in price area 4, I would use the Nord Pool area 4 asset, which has that information. And if I wanted for one of the other ones, I could switch. So it's the same model and it's the same binding, which I can make use of in different areas, depending on where it's installed. So it has quite a lot of flexibility. And what I need to do then is simply I choose for this specific telemetry value called Nord Pool, I choose a source model, and I choose a signal, and that is called value. And simply that means that this is now getting data from this one. And we have this set up already. So I'm just going to show you how this looks like on one of the car chargers where we have connected this. So this is another car charger with battery. And then we also have this area which shows the Nord Pool, current Nord Pool price, but also has this functionality we call cost steering. In a normal case where you roll out this to all your devices, you would automate this. and you will probably not do anything in the UI at all. But when you're developing this and testing it, and of course for these purposes, when we show this, we do some manual things here, which in the UI simply to show how you can turn on and turn off things and control it. So the idea behind this functionality is that the charger itself doesn't need a connection to Node Pool. Let's say that I either for some reason don't want to update the firmware, or we can't, or it doesn't have that type of control. So instead, we add that value through the cloud service. So the cloud service takes in the data from Node Pool, and then if we choose to turn on this cost control for this charger, the cloud service will start telling it telling the charger how it should behave. So now it's time to charge the battery, and now it's time to stop charging the battery, depending on the price. And if we go in and look at this as a specific, this specific one, and now I go to another view, which is more of a dynamic view, which is not a dashboard, but here I also have access to all the commands and all the properties on this one. We can turn cost control on and off, which are commands that they'll tell the cloud service to start working with this charger in that way. And we also have some properties we can set. And the important one here is that we have a threshold which sets at what threshold should it charge. And usually this might be dynamic in some way, but here it's a fixed number. And we're going to actually set this. So we see that the Node Pool price right now is 90. So let's put this to 100, which means that it's actually, it should charge because the cost is lower than what this threshold is. So I save this. We give this a send, and we let's see what happens here. We update it, and it's done. And if we go back to the device now, to this view, we see that the cost control charge station is turned off, and we also got an alert down here. Usually, these alerts wouldn't be sent this way. These would be automatic things turning on and turning off things. But what this is showing is simply an indication that we have a charger that has the Node Pool steering available. Price is actually lower than our threshold, so it means that we would like to charge the battery, and it also checks that it's actually not turned on at the moment. So this is just a warning of saying that you should probably want to turn this on. That would be beneficial. And as I said, usually this would be fully automatic in the back end once you have this rolled out completely. So I acknowledge this alarm. I mean, we don't need to, we know about it. It's still there because it's still happening. But we go back to the asset details, and now we turn on cost control. We wait for that to have an effect. It's not much, and we see up here to the right, it says low cost charging battery, and we can go back to the overall dashboard. And now we also see that the alert disappeared. So what happened is that I acknowledged it, but it stayed there because it was still being active. It was still triggered all the time, but it was acknowledged. But once it actually stopped triggering, as I had acknowledged it, it disappears. So now this is saying, so it's a low cost, and now it's charging the battery. And yeah, we see the battery charging kilowatt is now 29 kilowatts. And if I go back and turn this off, just to see an example of it, actually we can, I've turned it back on again. And what I'll do is that I will simply change the threshold to a lower value. Let's say it's still 90, so I'll switch it to 80. And let's look at the details here. Yeah, it's a high cost not charging battery at the moment. It's simply this panel on the dashboard that's not updating all the time. So that's the very basic way of how you can make use of data coming from external sources. Of course, there's probably as many ways you can make use of external data as there is data available. But there's not only, you can bring in data, of course, like just behaving as any other device and telemetry, but you can also use it to augment or increase value of other devices. Or, I mean, even if the device is actually can take use of this Node Pool data itself, you might bring it through the cloud and then send it down to the device this way instead, rather than having the device having to work with an API towards cloud services. So it all depends on the setup that you like.
I would just like to stress that this simple example shows that you can actually do quite a lot of advanced control from the cloud with a, what should we call it, simplistic device that is not intelligent at all and does not know anything about the energy prices. And then I guess you could, of course, in your specific business, wherever you guys are coming from, you can apply these kind of principles to your own devices and those external data and knowledge that you would like your devices to be controlled by. Then the way to make these provider service integrations are then different from data source to data source, so that we need to understand exactly how the data is sent from that data source, and then we have to wrap that data source into the beacon tower format. And it can be hard and it can be easy. There's no easy way to say how that will be done, but normally our experience is that it's ranging from a couple of hours to a couple of days. We're not talking weeks of work.